Atoms are the building blocks for minerals, and minerals are the building blocks for rocks. So this is kind of where we've been going with all of this. So we're going to start talking about the rock cycle and the various types of rocks. So first you should know that there are three major rock types: igneous, metamorphic, and sedimentary. And as you can see in the diagram of the rock cycle here, you can see that any one kind can change into any other, meaning igneous can change to metamorphic or igneous could change to sedimentary. So while it is a cycle, it doesn't have to go in a particular order. So any one rock type can change into any other rock type, and there's also several processes involved in the rock cycle. So melting, of course, means what it says. It is taking something solid and changing it into a liquid. Cooling and hardening is the reverse of that. Weathering and erosion. So weathering is breaking down of materials, and erosion is the transportation of those materials. Cementing and compacting have to do with making those sediments, compacting them closer together, and then making them stick together through a process called cementing. And then you have extreme heat and pressure. So Bowen's reaction series has to do with rocks cooling and hardening, and it explains the order that the minerals harden in. So notice up here I have higher temperature, and as I move down the chart, I begin cooling into lower temperatures. And so different rock types tend to cool at different rates. And then you also have in here the minerals involved in those rock formations. So this is called Bowen's reaction series. So let's start with the first type of rock, igneous rocks. These are rocks that form from magma or lava cooling. So what we have here in the picture is a picture of obsidian. This is a rock that cools very quickly, which is why it has this glassy appearance. So there's a couple of types of textures of igneous rocks. You have the intrusive. Intrusive reminds me of the word interior or inside. And so these, in fact, form inside Earth, so from magma. That is compared to extrusive, which reminds me of the word exterior or exit, both of those being on the outside of Earth or the surface of Earth. So these form from lava cooling. So the intrusive tend to have larger crystals because they were allowed to cool more slowly. Compare that to the extrusive rocks. These tend to have smaller crystals because they cooled more rapidly or quickly. So here's some of the textures. Coarse grained, that would be this picture. You have fine grained, you have this picture. You have porphyritic, which is kind of a mixture of both, large and small. Glassy, as in this case of this obsidian, and then vesicular, which means it has holes, as in the case of this piece of pumice. So composition of igneous rocks, they can be one of three types. They are felsic, mafic, or intermediate. So felsic tend to be light in color because they are rich in silica. Mafic rocks tend to be dark in color because these are rich in iron and magnesium. And then, of course, your intermediate can have a mixture of both. So this sample of diorite here, and andesite is another example. You'll see both light and dark colors in this picture. So transitioning from igneous rocks, we're going to now look at sedimentary rocks. And as the name implies, these rocks are composed of sediments. So basically you have compaction, that is taking loose particles and filling in what we call the pore or open spaces and compacting them. After they are compacted, then any empty spaces that might remain, oftentimes it's through water, are cemented together. So this might have water with some quartz or silica in it. And so when it begins to dry out, it is cemented together, forming a rock. So there are chemical sedimentary rocks. These form when the dissolved minerals precipitate out. Halite is a good example of this. So this is going to be naturally occurring salt, what people sometimes call sea salt. You also have organic sedimentary rocks, and they're called organic because they're made from the remains of organisms. And if this picture looks like it has a bunch of shells or even maybe some coral in it, That's exactly what it is. So these shells and pieces of coral have cemented together to form an organic sedimentary rock. You also have clastic sedimentary rocks, and clasts is a fancy word for fragments. And so these clasts or pieces are cemented together. So this is an example of a conglomerate. You'll notice it looks like a bunch of pebbles that have been cemented together, and that's basically what it is. Up here we have where it has a more angular, jagged look. This is called breccia. So this is a very similar process, but they formed in very different areas. This one probably formed in a glacier, and this one probably formed in an area near water. Transitioning away from sedimentary, we're now going to look at metamorphic rocks, and these rocks form from extreme heat and pressure. And the place where you're going to see that happen often is typically having somewhere to do with being near magma or where you have plates, tectonic plates colliding. So where there's a lot of friction and a lot of heat going on. So forming from contact or regional metamorphism. So contact is in fact when it comes into contact with the magma surrounding the rock. So at that location, you're going to have contact metamorphism. Compare that to regional metamorphism. This typically affects a large area. And again, typically what's going on here is I have two plate boundaries meeting, and at that location, I have an immense amount of pressure and heat going on there. So there are two basic types of metamorphic rocks. We have what are called foliated. This is a picture of gneiss that displays gneiss. Get it? Foliation. And then we have non-foliated. You'll notice this is a piece of marble that is not foliated. So foliated means that it arranges the minerals in it arrange in stripes or layers. And then, of course, the marble, you don't see that. So that's what non-foliated means.